So I try to be as concise and as clear as possible, so that more people can get a clearer understanding of what green buildings constitute, and how it contributes towards our more sustainable, low carbon cities. So what I've done is, I think, let me upload my screen. Have you uploaded? Can you share the screen? I share this one. Okay, I share. Okay. I will focus on 6 key areas which I believe will have a big impact on the low carbon cities. So the first impact, of course, is green buildings. Why green buildings important? Okay. Firstly, then I will start about planning for green cities. I think a lot of other speakers already covered that, so I will just skim through a little bit. Then the third one is cooler buildings. I think many speakers also talk about it, but I will like to emphasize this one because in our tropical climate, cooler buildings are the ones that contribute towards cooler cities, and also, of course, lower carbon cities. I think later I will show you some research done by UTM in collaboration with Kyoto University that shows 2 key elements are very, very important in low carbon cities. The first is actually the high cooler buildings. Second is the sustainable transport systems. These 2 elements alone contribute more than 70% of the carbon emissions of cities. Okay. Then I look at the landscaping and heat island effect. This one is actually, the microclimate of the city itself. If we have cooler cities, not only is it more livable, but also it contributes towards cooler buildings also. Okay, so and then lastly, the one that a lot of people don't like to cover is zero waste construction. What I call zero waste construction. This is the construction in Malaysia. We are already there already. Actually, there are a few companies already doing what we call industrialized building systems at the highest level. They have factories that produce buildings in the factory itself with as little as 1% waste, which they are driving towards zero waste. That's what I mean by zero waste construction. And then, of course, finally, we look at public participation, because like any effort that we do on a national level, without public participation, there is, we cannot go far. Okay, we can go deep, but we cannot go far. Okay, so the next one I will hang on, let me proceed. I don't know why it doesn't allow me at once. Okay, at once downwards. Okay, it's a bit slow, the reaction. Now, green cities are low carbon cities. Why is it true? Because it's very slow. Okay. I look at green building index. Is it the right tool? I think there are many tools in Malaysia right now. So we answer ourselves, what is a green building? The green buildings are the ones which are designed to save energy. They are harmonized to local environment. They are able to sustain and improve the quality of human life, efficient use of resources, and of course it sends the right message also. Okay, so the green building index actually is one of the major rating tools in Malaysia. We founded this, we started this initiative back in 2009 with a handful of architects and engineers, and of course industry partners. They're very important, and even the Malaysian developers also were part of the team in the early days. Now, the Green Building Index was, when it was founded, was one of the only 2 building tools that were able to handle what they call equatorial climates. Okay, if you look at it, it's one of the few tools recognized by the World Green Building Council. Okay, now in the Green Building Index, we emphasize on 6 key components inside the green buildings: energy efficiency, the indoor environment quality, sustainable planning, material resources, water efficiency, and innovation. Okay, so when we launched it in 2009, we developed 2 tools: one a non-residential tool and a residential tool. So if you're looking at the benchmarking of the tools itself, we have already 10 years worth of information, and this is real data already, 10 years worth of information, and more than 1,000 buildings, and more than 20 million square feet worth of buildings already certified already. And if you go back to the database, very important in the today's environment whereby big data become important. We can see we are learning from the from the past that we have now, data that we have. So this May 2009 we launched the building, and this is one of the first non-residential buildings. This is the residential building, and then in 28th April 2010 we launched the Green Building Index for existing buildings. Okay, so the Prime Minister building. We also launched the Sustainable Township in 2011. You can see many pilot projects going through in that one. Very important is our green factories. Why is it important? Because in Malaysia, more than half the electricity produced is actually consumed in our factories. They are important driver of our economy, and we have to make them very efficient, because in our tool we don't look just at the shell of the building, we look at the entire industrial process of each building that is submitted for approval in our Green Building Index. So this is one of the very unique tools. Other countries don't have it. Even Singapore developed their tools, also don't look at it that way. Okay, some early buildings that have submitted. Now the other important thing is even though we have developed 16, now we've gone to 18 tools already. So each time we find that there is significant progress in the industry, new information coming in, there are new ideas coming in, we update our tools. For example, our residential tool we developed in 2009, now already reached version 3 already. Why? Because we need to up our standard, and also we need to incorporate new ideas that we find from our big database. Okay, we need to do that. So it's on the ground data. It's important that we move forward and improve our tools also. At the same time, we need to emphasize that these tools were not developed in isolation. They were developed with the cooperation of all the respective industry. For example, our industrial new construction, industrial existing building, all those were developed with the cooperation of FMM. Our DBI tools for hotels and resorts were developed in conjunction with the hotel as owners association. So they give us data. We use the base data, and then we develop the tool, and when we ask back feedback from them, and then this is where the tool gets to be relevant to Malaysia. So it is a very relevant tool, unlike other tools which were developed without consultation with the respective industries. Then they lack that what we call street smart ideas that go into the tool and the reality of the tool. Because sometimes complex issues, we need a lot of collaboration so that we can go further in our whatever we do. Okay, so these are some of the developed, for example, the malls, and then the data exchange centers, hotels, all these certified buildings. So we have, as of February 2019, beginning of last year, you can see we already got about nearly total certified 500 projects, constitute nearly 1,000 buildings, really, more than 1,000 buildings. Okay, so if you do it by the register, we can see the majority of the buildings are in the NRNC, non-residential, then followed by the residential, the general two, then the rest are all less. And you can see the majority of the tools are also in the certified tool. Certified tool meaning they are best practices, buildings which have been designed to achieve best practices. Whereas gold tool, buildings that achieve gold, they are best in the nation. If you go to national, platinum, you are the best in the world already. Okay, and sometimes, although they are best in the world, in the universe, sorry, not in at least best in the world, sometimes the economics might not make sense. You see, so it has to be a proper balance. So up to the individual owner, how they want to achieve that. Okay. So you can see this is how we have been achieving that since end of 2018 and 2019 really. Okay, so in fact the BSIC forecast was for us to reach BEI of 136 kilowatt per month per kilowatt, the energy use by 2017, and our 800 buildings, you can see they were targeting about 800. We actually achieved that already, and 800 kgs of CO2 also was achieved back in 2017 already, actually. Okay, so this, if we look at it, how many million square feet, RNC was the biggest at 10 million, 9 million is the NRNC tool, and if we total it up, we have already reached 224 million square feet as of February 2019. Now already, I think we are reaching about 250 already, close to it. So these are the different, if we measure in terms of carbon reduction, 1049 tons of carbon dioxide. I think sometimes we are very difficult to relate back to figures like this, but they are significant measured figures which we are sending to the government every on a monthly basis. And also because we break it down to different states and regions, we also send to the respective states and regions who are interested. We send the data back to them, informing them of how they are performing in terms of carbon reduction and also how many green buildings they're doing. Okay, so this is a clear record. We are not talking theory anymore. This is real records and real data, which they can always come back to us, and we can feedback on them what they need to do in the coming 10, 15 years or 20 years or so. So you can see almost every state has got one project, except maybe one or two small states like at least the rest, every state has got one, at least minimum of one project. So state by the states. Okay, so a lot of people ask us the question, why form the GBI? The GBI was formed in collaboration between Malaysian Institute of Architects and ACM, Association of Consulting Engineers, and then we formed this what they call it, this intellectual property, to safeguard the intellectual property so that it's easily available to all Malaysians, whether they are developers, architects, engineers, quantity surveyors, or even town planners. Anybody can access the data. All our tools are online, all our guidelines, our books, everything, all the research, all our talk, even today's talk also will be online. You can see later on, we will upload it, and that's the website you can go to. Okay, this is the one of the website. Everything is free. Why? Because it's supported by our own institutes. We pump our own money in, and we are in the process of proposing to turn it over into a foundation. Okay, so this is a not for profit organization. Whatever profit we make, actually we power back into our research and development in order to gain more knowledge and improve our environment and make our country more sustainable and low carbon also, of course. Okay, so planning for green cities are of course low carbon cities also. Okay, the same thing, you look at sustainability planning and management. I won't go through the details of it. Countries which will not meet emission reduction target unless energy efficiency gains in the building sector are implemented due to lifespan of buildings. Failure to act now, energy efficiency and low carbon technologies will lock in detrimental energy and carbon impacts. This is a UN statement for Cancun 2010. So for buildings, you can see the cities produce 80% of the GHG, but they are also the ones who produce 90% of the economy and 90% of the the impact on the country. Okay, so that's why even though they are high producer of energy and high consumer energy, they are also the ones that are producing in country. So in Malaysia, the issues are rapid urbanization, relatively high carbon intensity, high private car ownership, low density developments, and low efficiency appliances. Maybe this one, less of it already. So I won't go through this one. These are the policies that we have implemented in the country about how we are going to tackle this low carbon problem in Malaysia. This is planning issues. And if you go to current special planning, I think I will go through this one. This one is also already covered by one of the earlier speakers, livable cities, sustainable cities. Now, KL is one of the few cities which have already started to produce their own blueprint and target for 2030 to be a low carbon city. This one is done again by University UTM, by Dr. in collaboration with Kyoto University. I think this same group have also done for Putrajaya and Cyberjaya the studies, and with that implementation, you can see the process of operation of plan. They have come up with 10 key actions, 38 sub actions, 83 measures, and 253 programs. So it's 70 low carbon emission measures, 70% reduction by 2030. Okay, so GHG emission modeling, you can see this one, they have done both to look at energy, waste, and carbon sink itself. So all these, I believe, are already available at the DBKL website, if I'm not wrong, because this one I attended the round table together with the UTM and Kyoto when they were doing the ideas. Okay, so some action groups, you can see green growth, energy, spatial structures, green mobility, and sustainable energy system. This one alone, 60, 80, nearly 90% of the programs are in there already. Okay, so what are we actually trying to do? We are going to, instead of allowing that movement through time to become to reach catastrophic levels, we are bringing our economy to become a low carbon city by taking actual measures and studying and what we need to do to reach these low carbon cities. So this study was done for Putrajaya and Cyberjaya. If you notice this, low carbon transport, cutting edge sustainable tropic buildings, 68% already, nearly 70% of the carbon contribution. We can reduce so much carbon by focusing on these two key areas alone. Okay, so I don't want to look at this detail, but I think the target set by Malaysian government by 2020, 40% of carbon reduction. I'm not sure whether we've achieved that or not, but I think if you look at our figures, I think we are quite close to it already. Okay, smart growth principles, I won't talk about it. Now, cooler buildings are actually, green buildings are actually cooler buildings. Low carbon cities are cooler cities also, okay? So when we look at energy, which is the key thing we want to look at now, you can see electricity, which are the biggest consumer of electricity, which are the ones that produce the most carbon. Actually, our plants, actually our electricity plants, you can see they produce about, they produce about half the CO2 that we have in our environment. And then industry, the less excluding cement, you can see that they are half of it only. So all our buildings, all our cities actually run on electricity. And unfortunately in Malaysia, many of our power plants are actually still running on coal-fired power plants. So we need to reduce that one. Now, local issue is, you can see high energy consumption per capita. Look at that, that's up to 2001. I don't know how we are doing, but you can see, want to compare a lot among ASEAN countries. The one country that has achieved very well is Singapore. You can see the blue color line just below the Malaysia. They have gone down, and then there's a big dip in 2000 because why? They have implemented policies for buildings to achieve cooler buildings, and also they have other green building features which they have started to implement and encourage in their cities. So they are able to bring down their figure for the usage. Now, in the typical Malaysian home, you can see air conditioning is one of the key issues. Refrigeration, cooling alone takes up already more than 70% of the energy used in a typical Malaysian home. Whereas if you look at office buildings, 60% is from the cooling load, air conditioning load itself. So in order to reduce the energy used in buildings and therefore less energy from the power plants, which is the highest carbon producer in the country, we need to focus on cooling our buildings. Not only the building, but also the microclimate surrounding buildings. So we need to understand things like OTTV, RTTVU values, and net zero. These are the things I will not go into detail. You can do research for yourself. But in Malaysia, if you are a low-rise building, 75% of your heat goes in through your roof. Double-story terrace, which is the biggest and most common form of building residential housing in Malaysia, 50% of your heat goes in through your roof. So you need to either insulate your roof or reduce the area of your roof. Which one you want to do is up to you. You can see for flats about 40%. So you need to either reflect the heat back or you insulate the heat from coming into your building. Okay, very important. I show you one example of how I measured. This is the Royal Mosque in Klang. I was engaged to assess their refurbishment of this building. They were trying to prevent leakage through the solid, all the concrete roofs and all that. So JKR did this project. This is the roof plan. You can see, I can show you. This is 2015 on the left and 2017 on the right. What is the big difference you can see here? You can see the not only the key highest temperature difference, 35.7 degrees. Here about You can see at the top, the highest point is at 43 degrees now. Whereas at this one here, after they have finished it, I went and remeasured again in 2017. The concrete roof temperature dropped to about 31 degrees centigrade at this highest point. At the point, this point here, you can see at that point is 35 and this is 37. So that is because when they refurbished the roof, they added insulation on the outside of the roof before they allow to add in this normal photo. So insulation has a big impact not only on the temperature of the roof itself. So imagine people go to prayer at 12 in the afternoon in the roof. The temperature at 31 is huge difference with 35. If you apply some fans down there, you can reduce the temperature down by another 2 degrees. So about 29, 28 degrees centigrade. So it's actually a lot more tolerable than if you stay at 35, 36 degrees centigrade. Okay. So you can see these are the same further pictures of the outside and inside of this, the outside before and after 2017. You can see the temperature differences. And then, of course, a lot of research is also done in Singapore. This one is measured by Professor Wong on National University of Singapore. This one you can see, temperature at a peak, this is over 2 days, at a peak can go up as high as 58 degrees centigrade. Whereas if you plant tree shrubs and on top of the roof, the landscape actually reduces temperature down to about 28 degrees centigrade. Here you can see this at the bottom here. Okay, so the other thing after the roof, of course, is the building envelope. If you have a tall building, low-rise building impacts less. But if you have a high-rise building like office block, apartment blocks, and all, more than 60%, 80% of the heat goes in through your elevations. Okay, so it's important that you understand what is OTTV and heat conduction through the walls, through the windows, and through the through the heat gain through the windows. So this is where I cannot go into detail on this one, but you need to look at this formula. This formula is now applied into what we call bylaw 38A in our uniform building bylaw. This has been amended in 2012 and it's already law already. So any building, non-residential building more than 4,000 square meters, need to apply this bylaw already. You see, and this is designated to meet the requirements MS 1525, meaning you have to insulate your roof and you have to reduce the amount of heat entering into your building. This is passive design itself, and this is already implemented in the law. Currently, we are waiting for all the other states to follow through with their state bylaws implementation. To date, 4 states have already, I think 4 states, mainly Selangor, Penang, Kedah, and Terengganu. These 4 states have already passed it into their local bylaw, so it becomes law already now. Any renovation, any new building, you have to follow this bylaw already. Okay, means you have to put insulation in your roof. You have to make sure there is no direct sunlight producing heat in your building. Okay, sustainable landscape is what we know as improving the microclimate of the building. This is sustainable planning. Okay, look at it. This is a profile measured in Singapore. You can see city center of Singapore. Typical heat up to 29, 30 degrees, 29 degrees. Whereas if you go to the outskirts, it can go as low as 24. So there is a difference in the microclimate. So if your microclimate is at about 39, if you have a lot of tarmac, you have very few trees, a lot of, hard surfaces which absorb heat, then if your temperature indoor is 25, you can see the delta T is 14 degrees centigrade. Whereas if you have a lot of water bodies, a lot of landscaping, a lot of shaded and light colored surfaces, your temperature can go down to as low as 32. So if you're minus 35, your delta T you're tackling is only 7 degrees centigrade. So 14 and 7, look at the big difference. This is where we as planning, microclimate planning, it's important to have as much landscape as possible. This is a typical effect. So urban planning, we as planner and a building designer need to put in more landscaping. I know in typical, under planning bylaw, they always say 10% of your ground area must be landscaping. And then a lot of local authority also don't give credence to vertical planning, vertical landscaping like this one here. You see a lot of vertical landscaping. This is some of the urban landscaping. So when you start to landscape at the upper floor, you actually contribute to the microclimate of the building itself. So this is one example. Singapore, they have done a lot of detailed research and encouragement of urban landscaping. I think they are the world leader right now in terms of urban landscaping. You can see this is Bangkok. This is one of my own projects. We have actually, if we follow strictly on the ground landscaping, we have only 10%, okay? But we started to landscape in the upper floors, the landscape floor, and then we also do the vertical landscaping, and then we have all our water bodies that have to cool. And then at the rooftop, we also have the landscaping. So by doing that, we have increased the landscape by 3 times, from 10% go up to 30%. And that's where we're helping the cool the building. Now, a very useful source of information about how you want to landscape your roof and your podium areas. You can go to this one, NPark Singapore, and this is one of the useful sources of information. Because I find that a lot of building owners, when I say landscape your roof, landscape your podium, they say, oh, a lot of leakage coming in. Actually, that's not the issue. The issue is doing it right. When you do it right, not only does the waterproof last longer because there's no swing in temperatures, but also it protects your waterproof layer, and it keeps your microclimate cooler also. So actually, it's the technology of how to do it correctly, how much to use, and when to use it. So this one is in Singapore, they've done a lot of research about this. Go to that website and bring the information. The last, almost the last one that I want to talk about is zero waste construction. What is zero waste construction? Now, earlier on, Renu has talked about, Reni is talking about, the cycling economy. There you recycle everything. Now, in the construction, data from the world data, it's very clear that construction constitute about 40% of the total dump site waste, solid waste. We're not talking about organic waste or anything here. Just solid waste in all the dump site. 40% comes from construction. If we do conventional construction, typically we contribute a lot of waste. Okay, so we want a linear city whereby less go in and less come out also. Okay, so this is the idea. Now, the solid waste management data for KL, you can see we only recycle about 5% of our waste. What we want to do is we want to reduce the waste going into our landfill by reducing the waste first. Then we reuse whatever we can. Then we recycle, and then before we even think about incineration. But I think that's not the ideal incineration. Okay, so to reduce the waste, the reduction, zero waste construction, we need to emphasize on 2 things. One is the building information modeling, which is the new technique of designing building to reduce the amount of waste coming out of the building. And then what we call IBS integration. When we integrate these 2, we are able to produce buildings which are, let's say, for example, this one here. If you are using conventional construction, you can see you've got to hack off and re-cluster again. Whereas if you use precast systems, you can see the line can be produced with minimum quality issues. Productivity also improved almost double. Okay, this is a study done by a researcher in Singapore. Buildability score is what is our IBS score, and then the productivity. The higher the buildability score, the better the productivity. You can see this line here through a few hundred buildings here. You can see. So actually, it is worth doing it. And the other is we reduce the amount of waste generated. Typically, this is done by this research done by Destari back in 2009. You can see here they took a fully prefabricated building, 2 tons per square meter, whereas compared with conventional, we are producing 50 tons, almost 20 or more than 20 times more waste generated in conventional construction. Okay, so how do we actually calculate the IBS score? You can see, I don't want to go into detail of this one, but you can see the structure is one of the key elements in producing it, the walls, and suddenly the other matters. Now, I don't work for Gamuda, neither do I have anything. I'm not advertising for them, but they have actually brought in a system. They have now got 2 precasting plants which are fully automated, which can fully accept BIM data. Once the BIM data goes in, what happens is they can convert it into how many slabs they need to produce, how they can quickly lay out the slabs and then start to produce the concrete slabs. See, this is an automated process. Everything is automated. Okay, so by doing that, actually they have managed to reduce the waste. In the early days, I believe they are about less than 5%. Today, they are already pushing towards less than 1% waste. Imagine a building whereby you go in there, everything is produced in the factory, take out to the site, and then they install, and that's it. Already, you have finished the building. Already. There's minimal waste of products. So it's fast, about 12 months improvement, more efficient, reduces foreign labor, and minimal waste. Now it's already down to less than 1% of waste coming from factory. But I think there is they call it cost of building issue. So this cost of building, I think roughly from my own experience, we have done so far, only about 4 to 5% extra cost for the building. But when you look at the overall cost, actually it's cheaper, the building, when you don't go back to the look at the overall picture. When you look at the rework portion, which a lot of people don't look at sometimes when they go into a building. Rework is actually a reality in life. Sometimes when you do the thing wrongly, the house buyer or the owner don't want that finish. The quality is not up to his specification. He asks you to hack off and redo. That can be up to between 5 and 15% of your total cost. So a lot of people who do research in this don't take that into consideration. That is the reality on the ground. Okay, so how do we get more people to participate in this low carbon initiative of Malaysia? Important that we participate through organizations like MGBC and WGBC. Now, MGBC is one of the earliest green building organizations in Malaysia. We actually are a member of WGBC. We have our established member in, I think this is 2011, okay, about 2 years after we formed the organization. And WGBC is a global green network. And we are part of the Asia Pacific region, which is this part here, the green one here. And I can see we rate, we educate, we advocate, and collaborate. Okay, these are the world GBC roles. We contribute towards green cities, national policies, existing building, healthy buildings, and high performance buildings. These are the key work of GBC, which then filter back down into Malaysia GBC. If you look at the world figures, we have already done 1.2 billion square meters of buildings in 31 countries. 5 net zero building certificates have been issued. And can see these are the figures that for worldwide figures. Okay, so I know I've gone too fast, and there's a lot of information available both in Green Building Index and WGBC. If you want to contact me, you can come through this website, this email here, malaysiagbc.org.my. And so with that, I would like to hand back to our organizer for him to answer any queries that you have. Thank you very much.